Well, good afternoon. I guess a former of the CTO office, but not the CTO. My old boss would probably take issue with that. But welcome. What we're going to talk about is immersive training. And since I have 40 years experience in the oil and gas business, that's the only thing I know. So it'll be very slanted towards the oil and gas business. So what are the business drivers that are sort of making us look at immersive training, and why, what are some of those factors? And like previously mentioned, the great shift change. So we have a huge amount of people retiring, and we have a desperate need to train people to fill those roles, and the training needs to be efficient and effective. The second thing is the conventional training is just not very effective. It's expensive, so you have things like travel, or you have instructors that you're moving around, things like that. And overall, you're not achieving the end goals of changing behavior or getting the learning in place. The other thing in the oil and gas business is, as mentioned before, the consequence of getting it wrong is high. So you need to make sure that not only are you cost effective, but also your training is effective. And likewise, what's really changed in the last little bit is the consumer market has really driven the whole immersive environments to where, one, the price is coming way down, and secondly, the acceptance of those. A friend of mine went to get a new phone, and Samsung gave a virtual reality glasses free with the phone. So things have changed that much, where you're really seeing the consumer market driving a lot of this technology. So what is immersive learning? It's really all about placing an individual in some sort of interactive learning environment. So it can be physical. I remember when I was in Anchorage, they actually had a DC-3 trainer that was a physical trainer, and it looked more like a washing machine than a simulator, but it trained pilots on DC-3s. So that was a physical one. When obviously we have the virtual environments, and where the simulation comes in is in an immersive environment. You can run these scenarios through again and again, and things like that, just like we just heard of. And so now I'm able to, in that environment, run through lots of that. So that's what immersive training is. You put somebody in an environment that is realistic, and you can run through lots of training exercises. In the oil and gas business, what are some of the things that we use it for? And you can obviously use it for basic training needs, but as mentioned previously, you probably shouldn't involve immersive training for sort of low volume, but you do see that around. Where I really see the potential is and again, this is mentioned too, is the less frequent, higher consequence activities. So a classic example in my mind is when you launch a pig in a pipeline. It's very important that you get those steps right, and that you don't leave any of the steps out. If you do, somebody's going to get hurt, or you're going to damage the environment. So we do a lot of that stuff, and if we did that every day, it wouldn't be an issue, but we do it every 6 months. So it tends to be something that a trainer is a great opportunity for. Of course, we just saw a great example of commissioning. So again, the ability to work on something that doesn't exist yet and be able to train on it is great. Business process rehearsal. So the ability to step through a process again and again till you get it right. So think about a maintenance activity where you want to go in and simulate a lift where you're going to lift a pump over a set of pipes, and you need to make sure you have enough clearance between those pipes and that pump and that crane and the position of the crane and all that kind of stuff. It's a lot easier to do that in that and practice it again and again, so when you're shut down and you're doing it, there's no surprises. The picture on the bottom there is a business process rehearsal for when BP Alaska rebuilt one of the flow lines on the North Slope, and they actually stepped through all the things just to make sure that stuff was going to work before they got into the field. And then the last one is any kind of high-risk environment. So the analog is the flight simulator. I can practice lots of dangerous things safely, like losing power on takeoff and things like that. We can do the very same thing here. The three key benefits of immersive training: lower delivery costs. So not think about just one component of it, but how much does it take you to develop it? But more importantly, how much does it cost to deliver it? And if you're flying people in for conventional classroom training, if you're doing things like that, you have to factor in all those there. And the virtual world can many times be delivered to remote places very cost effectively. The second big thing is the retention rate. So it's one thing to deliver training. It's another thing to actually have the people get to retain the training that they receive. So that's a very important. So that's how effective is that training. And the third component is that you really can lower your error rates. And in our industry, where the consequence of getting that wrong is so high, that's very important. So what we're really saying with this immersive learning is that you have the classic learning pyramid, and the most ineffective way for retention is exactly what we're doing here, where you're listening to me, right, lecture. Not very effective. Reading is not a whole lot better. Audio visual, a little better. But it's really when you start to get into those virtual worlds where you can do the demonstration, the discussion, but more importantly, the practicing, just like we've seen, where I do it again and again and it becomes second nature. That's where the retention rate goes way up. And then the best thing, and I love the comment about train the trainer, one of the best ways to get retention is when you teach it too. So again, the reason that immersive learning is so effective is that you go back to the basic principle of how we learn, and immersive learning allows us to do that. So what's the benefits of it? University of Iowa Ames conducted an experiment. What they had was a mock wing that you were supposed to construct. And so you had to assemble this wing. So you had struts and other sorts of things in it. You had three groups. The first group had the instructions in the classic PDF standard procedure kind of thing, and it was on a desktop that was separate from the assembly table. The second group, they had the same instructions, but it was on a tablet so they could take it right to the assembly, and then so as they started the procedure, they did that. The third group, though, had what's called augmented reality, and what that meant was you held the tablet over the assembly area, and then the first piece that was supposed to go in, the was computer generated, and it would show you right there how to put it in, and then the second piece and the third piece and all that. So you're using that. And what we found from the study is that the augmented reality, the immersive learning environment, they conducted this twice for each group, and they found that the time it took to complete the task was significantly less for the augmented world, and the amount of errors they made significantly went down. And this is even after you repeated the same assembly using the other techniques. So clearly there's that this immersive learning goes back to that learning pyramid, and you're able to have just so much more effective and efficient training. So that then gets into what are the environments that I can do this immersive learning in. And the three that I'd like to talk about are first the virtual reality. And there's a lot of confusion between virtual reality, augmented reality, all that. But the key takeaways, and I'll just see if this plays up. There we go. So the key takeaway on virtual reality is that everything in it is, in fact, not real. So it's computer generated. And the idea of the learning environments is that you then can go into this virtual world and conduct a number of tasks again and again. You could keep track of how well you did on these tasks, and did you get it, kind of thing. But the key thing is that you're working in a virtual world. And there's three types of virtual worlds. There's sort of the non-immersive, which are sort of the Xbox on the TV screen kind of stuff. You also have sort of the cave environments where you have lots of screens around and you're sort of immersed with these screens. And then, of course, the third that we've all seen are the virtual reality goggles and things like that. But the key thing is all those involve some sort of simulation in where everything is not real. The second is augmented reality. And the difference between virtual reality and augmented reality is in augmented reality, you have something that is real, and then then the computer generates an image on top of it that's not real. So you're augmenting the actual, reality of that. And see if this plays. And so this is just a quick example of an automobile manufacturer. You take the tablet registers over the engine, and now it recognizes the engine as an object, and it knows it has a bunch of basic maintenance procedures now that you can project over the top of that to show you, like, where is the oil filter, where is the how do you put water into the radiator, or whatever else that might be to do. But the key thing is that you're combining computer generated stuff with real stuff. And that's the basic difference between virtual reality and augmented reality. And then the last one is a little different than the blending technique that we do. I call it hybrid. And what I mean is that you take various components of immersive learning and you combine them. So the first one would be a classic one where you have a physical well house, drilling house, and those things are real, the levers and the gauges and things like that, but obviously the virtual realities being projected there. So that's a mashup of physical and virtual training. The second one is where you would take and try to take the best of both worlds. So live instruction has a lot of benefit where you can stop and ask questions. If you don't get it, you have the interaction of the class. but it tends to be pretty costly and hard to deploy. So what if you mashed up things like WebEx, a WebEx-like session, so you could have your classroom environment, but then when you go to practice the things you learned about, then you have the students go into a virtual world where they conduct that practicing that we talked about. And then, so you can combine those sorts of things and get the best of both worlds and sort of minimize the disadvantages, because each of these techniques have advantages and disadvantages. So those are the three categories of immersive learning environments that I sort of see out there. Another key thing, you need a 3D world then to have this immersive environment, right? And so what I see is a lot of confusion because there's so many different types of 3D worlds. So what you want to do is to categorize those models by two major parameters. Number one, is it exact or inexact? And by exact, I mean it from a metrology perspective, for a surveying sort of aspect. In other words, do you know the accuracy and precision around those measurements? Are they, repeatable and things like that? So you have exact models and inexact models. And then the other thing is, are you modeling something that's not real or something that's real? So there's basically 4 types of 3D models. So what do I mean by all that? So if you look at the unreal, inexact, think of Lord of the Rings, right? Fantasy world. Dimensionally, those castles and volcanoes and all the other things aren't exact because they're not real. Okay. But also conceptual drawings and things like that can be sort of in the same space where you're trying to just get the concept across, but you don't care that the wheels are too big or, that there's not a bumper or, things like that. Now you get into exact representation of unreal stuff, and the classic example is CAD, 3D CAD. So I've modeled something that I have not built yet. So I'm in the design phase of a facility. Also, it's very useful when you want to have a generalized environment for training. So it's not a real refinery. It's a sort of a generalized refinery, but it doesn't represent any one refinery per se, but it has the basic components of it. But it's all, so it's not real because it doesn't exist, but it's very exact representation. BP did a training simulator for their gas station retail people to sell the high margin stuff, which is food. And they taught them how to prepare it through a simulator. And what they did was they created a virtual world, which was a generalized what a typical retail store looked like. And it had the typical kitchen in the back and things like that. So again, very useful with that. The next one is where you're modeling real stuff, but it's inexact. So think about things like photogrammetry, where you're taking a lot of pictures and all that. And the problem with that is it looks very exact, but in fact, the measurements, it might be plus or minus 10 millimeters in this part of the scene and plus or minus 1 millimeter in this scene. Not a big deal unless you're counting on those measurements to be right. And think again about your business practice, your business process rehearsals, where you want to make sure you have enough clearance, and it would sort of be bad if you're off, right? But for lots of other things, it's very attractive because the amount of effort to make an inexact model is less. And then the last one we have is a real exact, and what that is your classic laser scanning. And so you go in, it's very precise, it's something that's real and all that. So what you tend to see with that though is you compromise the fidelity, the rendering of that scene for the accuracy. So you want it very accurate. And what's cool about that though is if a pipe sags in the middle, it sags in the middle. It's not a generalized, this is a 90-degree bend. It might be 89.5-degree bend. And if you're running 300 meters, a pipe, that half a degree can be, significant. So what are some of the reasons we don't see more immersive training if all these benefits are there? The first one is, as we sort of mentioned, is many times training is seen as a cost and not an investment. So I was glad to see the kinds of numbers that I saw where you can say, you invest $9 million and you get $18 million back, that kind of thing. That's a good thing, and that attitude has to change. The other thing is you see training departments that are sort of embedded with their conventional training tools, and they sort of want to stay with it. Another thing you see a lot of is that there's no funding. They say, yeah, go do the immersive training, but there's no funding to do that. Another big barrier, though, is it can be really expensive to create models, and that's why I went through the matrix. Is that you want to make sure, because you go, wow, it can cost $1 million to create an exact model of a refinery unit and things like that. Then, if you have an exact model and you're trying to simulate on that, keeping that model up to date, whether it's the simulation code in the back or the actual 3D model, can be very expensive. The lack of intrinsically safe field devices, again, Google glasses and all that kind of stuff is neat, but in the environment that the oil and gas industry operates in, it has to be intrinsically safe in many cases. So the lack of field devices has been a big barrier. There's also one of the big things that I've seen is, people use the wrong model for the wrong purpose. And so if you have an inexact model and you're taking what appears to be, because the computer will give you to 20 decimal places that measurement, but if you don't understand the accuracy behind it, what you can do is misuse those models for things that you're trying to do and not even know it until you get into the real world. And then you come back and say, well, I did the simulation and it didn't work. I didn't catch that kind of thing. So it's very important to put the right 3D model in. So the trends, you see the consumer market will continue to drive down prices and acceptance. You're going to see the military really drive a lot of this area because they have an enormous training need. Again, high consequence, if they get it wrong. Obviously, you're going to see a lot of wearables come there. And for augmented reality, especially object recognition and gestures and things like that, will really improve that technology in the sense that I can recognize one pump from another pump, the subtle differences, and I can control it without having to use keyboards and things like that. So that's going to really help a lot. And then you're going to see a lot of scanning technology that will really bring down the cost of creating these immersive learning environments. And then recommendations, make sure the model you pick is appropriate for the task at hand. Don't spend the money to have an exact model if an inexact model will work, but also realize that if the task changes, you might not have the right model. So make sure the interface is appropriate. So many of the 3D worlds, they started out as almost CAD-like interfaces, great design tool, but not a training tool, right? And stay away from the wow factor. People get really hung up on the Google glasses and the virtual reality glasses and things like that, but really get back to the business case there. And fundamentally, before you take any of this on, and I was glad to hear that too, is you have to make sure that you can change behavior. So really make sure that you focus on that. So what you're really looking at then is you want to drive down your total training costs while improving the results. And with immersive training, you know, you can do both. Okay.